Hello. I hope that you guys can see me. Agar dekh pa rahe ho, like I can see the chat of Chetan, MS Darshan, and Noman. Yeah, Noman. I don't know how to pronounce yours. But yeah, if you can guys see and hear, then please एक बार लिख दो that it's okay, done. पता नहीं कितना फ्रेम में आ रहा है. Yeah, it is, yeah, now. And okay, sorry. Yeah, like I've just opened यहाँ पे YouTube live stream to actually see. बता देना भाई कब शुरू करना है. Let's wait for a minute. Let's assume that you guys are seeing. देख रहे हो, एक बार लिख दो फटाफट. Yes, ये hey Aryan bro, nice. Hi भाई MS Darshan. Who are me? Please teach policy based data structure for third question. Yeah, for the third question, the initial thought I had was for the policy based data structure, but I tried and it failed, and then I realized that it failed because it had duplicates, because it can't work on duplicates. And like I legit tried. I just teach that like it's very good, which your set multi-set it can't do, your index set it can do, which is a policy based data structure. So yeah, for third question you will see policy based data structure. Ajay Kumar Seelam is here. No man, yeah, Aman Mishra is here. So shall we guys start करते हैं यार. मतलब लोग तो नहीं है. Please stick to English bro. Yeah, we will stick to English and we will just try, like let's have the stream in English, and then we can see in the next streams and next things that how things goes. And cool. So shall we guys start with the questions? Like I can't see. Yeah, like we thought of let's have the stream in the night at 10, but then I thought that because of that maybe it's way too long for a stretch, because let's say you have the contest gets over at 9:30 a.m. and then you go and see at 10 p.m. then it might be a bit long. So I thought that why not have it at 11 a.m. or maybe around like near about when the contest ends. So yeah, let's start. Ashish and Shubham also said yes. So yeah, let's begin. I'll just switch my place that you can see. So yeah, let's quickly, like we'll just go on. Every thinking I had while doing the contest, I'll just show you guys, so I actually can interpret okay what all thoughts comes for every problem you see. So let's start with the problem itself. You will try to code also, like you can just let me know if you also want that we shall code or not. We'll for sure try that. It's very simple, and you can also get the intuitive idea. Okay, if we just submit, then what all cases we have to think while solving the problem. Let's start with the first question itself. It was very easy. Like in standard, what Leetcode gives the first question as, it's more easier than this. So yeah, let's start. Calculate delayed arrival time. You are having a positive integer arrival time, which denotes the arrival time of the train in hours. A train comes at this particular time, arrival time, and another positive integer called as delayed time, which means okay, the train is delayed by this time d, and this is my arrival time. Let's say this, which denoting the amount of hours which the train have been delayed when the time when the train will arrive at the station, which means arrival time, and this the train has been delayed by, let's say, this TT time, so we have to just add that. Note that the time in the problem is in 24 hours format, so it will just reset after 24 hours. Let's see the problem. 15 is the arrival time, 5 hours it delayed, so in total it took 20 hours, and in 20 hours our time is actually in 20 hours, so we can just return 20. That's all. Train arrives at 13 hours, it delayed by 11 hours, so 13 plus 11 is nothing but 24, but our timings are a 24-hour format, which means it can go from 0 to 23. Thus, I just moved it back to 24, which means it's just modulo with 24, that your answer will always remain in the range of 24, which means from 0 to 23. So whatsoever answer you get, you have to do a modulo 24. And that's pretty much it for it. So let's quickly code out the problem. I'll just reset this. It's very, very, very simple. See, you have this arrival time, you have this delay time. Let's name very short that we don't have to write anything more. So let me know if you guys want to increase the, yeah, I just increase that. We have to return what? We have to return nothing but arrival time plus delay time, but it needs to be in the range of 24. Thus I have to mod with 24, and that's pretty much it for this problem. Let's submit it, and yeah, it was pretty easy. It's accepted. So yeah, that's all for the first question. It was actually like legit very, very easy. As I said, codes for C and D, bro. Yeah, we will go on to the next problem, which is let's go on to the next problem. Like, we'll go order-wise for sure. We'll go on to B, C and D also. But yeah, ye bata do, like, please tell that audio and video quality is good or not. If anything else needs to be added or reduced or changed or modified, just let me know. And yeah, please do hit the like button, please. You have 15 people and you can like. It's just if you like it. Next, moving on to the next question. It says sum multiples. It's also a very easy question. We'll just move on in this problem very quickly. It is saying that we are having a positive integer n. Cool. N we are given. Find the sum of all integers in the range from 1 to n, inclusive that are divisible by 3, 5 or 7. It is just 3 numbers that we have to check for, that the numbers from 1 to n should be divisible by these 3 numbers, and we have to find the sum of all those integers between the range from 1 to n which are divisible by 3, 5 and 7. That's it. It's a pretty basic brute force solution. Return an integer denoting the sum of all the numbers which are in the range 1 to n which are divisible by 3, 5 and 7. Let's see first question. It's standard. Firstly, whenever we think of anything, first we think of very brute force solution, which means I'll go on to every of those numbers and check if this number is divisible by 3, 5 or 7. If it is yes, then I will add it in my sum. If it is not, then I'll just move on to the next number. Can I perform this operation? Yes or a no? Yes or a no? It is decided on the basis of constraints. I have what operation I can perform is I will go on to every element from 1 to n and perform 3 operations. On every element, I will check if it is mod by 3, if it is mod by 5, if it is mod by 7. If any of these is valid, I'll just do okay. Just add this number in my answer. Let's say the number is I, add this number I in my answer. So it is nothing but O of n into 3 for this problem. Cool. Can we do it? Yeah, we can for sure do it. It is constraint is nothing but n is less than or equal to 1000, and it means that we can do it. Let's see how. It was just that, okay, I just move on to every problem. 3 or 2, no, not sure. 3, yeah, for sure it's good. So I have 3, 4, 5, yeah, for sure. I will add 5, 6, yeah, it is mod by 3. So 6 can be in my answer. Can I have 7? Can't it be? No, like it can't be mod by 3, 5 or 7. So for sure it's not. So answer is nothing but 6 plus 5 plus 3. Oh, wait a second. We have to go for every of those numbers in the range. 7 also was an option. Why? Because we can mod by 7 also. So the answer is 7 plus 6 plus 5 plus 3, which is nothing but 21. It's also very brute force. I'll just go on to every number from 1 to n and we'll check if that number is mod by 3, 5 and 7, and I'm good to go. And same goes for 9 also. Let's quickly code this problem. I'll just move back to our problem. Let me reset it and let's see. So basically we have n numbers, and I said I will have firstly an answer. So basically I have this answer. I hope that screen is visible. I'll just zoom it in bit. I have answer which will actually store the sum of all those numbers which are divisible. Then I have to iterate on every of those numbers from 1 to n, right? From 1 to n, I'll just go on to every of those numbers. Now, as I go, I have to check 3 conditions. If that number, now the number is I, if that number I is mod by 3, okay, or that number I is mod by 5 or that number I is mod by 7. If that is the case, then I have to add the number I in my answer. If it is not, then I have to do nothing. I have to just go on to the next problem and then ultimately I have to return the answer. Because our condition was I have to do mod by 3, 5 or 7. Let's quickly submit it. It's also pretty easy, so it will get accepted. I hope that it is done. And yeah, we have Shubham, Lean Learner, Shiva, and MS Darshan was always there. Shiva, MS Darshan, Aman, Noman, Ajay Kumar. Yeah, so cool. Let's go on to the next problem, which is problem C, which you guys have been waiting for because problem A and B were pretty simple. Let's go on to problem C, and in this problem, I'll actually show you how I thought. I never thought of this, that how easy it can be. I thought it of a hard way. But what hard we can teach you right here in this problem, see, it will not get implemented by this, what I'm gonna teach you. But it will actually help you in other problems. Legit. What I will teach you first in this problem will be a policy-based data structure, which is I will just show you. I will not teach, like say right now. But after that, we'll actually see, okay, why it was wrong and how I thought, okay, it can't be worked. So let's think of something else. Cool. Harsh Patel is here. Bro, do third question. Yeah, third question is here. And if you guys are liking it, then please do the like button. We have people, we have your enthusiasm, and I am also like super excited. Siva, I did the insertion sort brute force thing, got TLE. Yep, for sure, because the constraints were large. Let's look at the problem itself. Let me quickly change to my tablet, and here we go. Firstly, we have one thing, okay, sliding subarray beauty. Given an integer array nums containing n integers, okay, nums is having, okay, n integers we are having, cool. Find the beauty of each subarray of size k. Find the beauty of each subarray, which means I have this particular nums as my array. I have to find the beauty of each subarray of size k. Subarray is nothing but continuous portion of elements. Cool. Of size k. K is also defined. Cool. The beauty, what is the beauty of that subarray of size k is nothing but the xth smallest element, which means if I have elements, let's say I sort the elements, then if I have -3, -2, -1, 1, 2 and 3, then if I say x is equals to, let's say 3, so I want the third smallest element in this particular thing right here. It will be nothing but my -1, because the first smallest element is -3, second smallest is -2, third smallest is -1. So I have to give the third smallest, which means the xth smallest. X is also given for you. I got in that question. Hey, go from brute force to the optimal, bro, so we could grasp the thought process. For sure. Wasted 20-30 minutes. Time implemented it in a stack. KK. What's not about KK? But yeah, x is nothing but what we are having. Okay, is the x smallest integer in the sub array. If it is negative, okay. If the number, what is the xth smallest number? If it is negative, I have to give that number, which is negative number. But if it is positive, let's say if I have said, okay, let's give me the fourth smallest number. If you would have provided me 1, then I would say no. If the number is positive, then give me 0 instead of that number, positive number. Cool. If there is fewer than x numbers, x negative numbers, which means if my x smallest number is not a negative number, so I have to return a 0. It is what the problem is saying. Return an integer array called containing n minus x plus 1 integers, which means I have this integer array of length n called as nums. I have to go on to every of the subarray of size k, choose the xth smallest element, and I have to repeat the process for every, which means I'll just change the color, for every of those k. Okay, again change the color of those k subarrays, right? Which means I will ultimately have a sub array of size n minus k plus 1, which will actually have all, like for every sub array of size k, x smallest element, x smallest element, x smallest element, like this. Cool. Which denotes the beauty of the subarrays in the order from first to end, which means the first subarray of size k, then the next subarray of size k, then the next subarray of size k. Cool. A subarray, you all for sure know that it's a continuous non-empty sequence of elements within an array. Just that, okay, I want a subarray, it is just continuous portion of elements, and I want the size as exactly k. Now just quickly let me know what you guys thought of in this question, and I'll just let you know why that can't be possible. If you are confused at why that can't be possible, if someone was saying that they tried brute force or something like that, then for sure you can see you can't do a brute force. Why? If you look at the constraints, firstly, let's quickly look at the example. If you guys are watching, please do the like button. I can see you guys and it helps me motivate. So cool. Let's quickly look at the example first. Then we will look at, okay, what you thought of approaching it and why that brute force approach which you thought actually is not valid for this problem. If you look at this array, which is 1, -1, -3, -2 and 3. Firstly, my constraint is, okay, I have to look for size k, which means my size k is nothing but 3. So I have to look for size k. Then I have to, okay, then another thing was choose the second smallest element in this size, which means if I just sort it down, so it will become -3, -1, 2. What is the second smallest element? It is nothing but -1. So in my final result answer, first element is -1. Cool. Now next, for the next element, I will choose the next subarray of size k, which is nothing but this of size 3. Now again I have to choose the second smallest element. Again I have to sort it, -3, -2, -1. What is the second smallest element here? It is nothing but -2. You can see next element is -2, which is my answer. Okay, cool, no worries. Then I have to look for the next subarray of size k. Then I will go on to the next subarray of size k, which is nothing but this -3, -2, -3, 2 or 3. Now I want what? I want the second smallest element. So I will just sort it again, -3, -2, 3. What is the second smallest element? It is nothing but -2. So I'll just return a -2. That's pretty much it. It is your answer. -1, -2, -2. It is what you have to return for every subarray of size k. Now you will say, Aryan, okay, we got it, we got the exact problem, how it is done. Let's see how it can be implemented. Firstly, very brute force. I will just go and do simple thing. I have this array of size n called as nums, right? I'll go on to the every subarray of size k. Cool. Every subarray of size k, every subarray of size k, I will just grab that subarray. What I will do is, I will just sort all the elements of that subarray of size k. It is of size k. It's a subarray of size k. I'll just sort all the elements and then I'll just grab the x smallest element. Cool. What do you think will be the complexity of this problem? Or do you think it will work? Which means you have the subarray, you have the array of size n. Let's say you grab the subarray of size k. Cool. Then you have to sort it, let's say k log k. Then grabbing the x smallest element in this sorted is just O of 1. But you have to do it for every of the element of n. Because ultimately you have to go on every of those subarrays. Let me change the color. Pink, 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 pink. Yeah, every of those subarray of size k. So this thing you have to do for every of those elements of n. Like not every, because in the last, when it is the last subarray, it will be up till here, but it will be nothing but last will remain the k elements. So you can just easily say n minus k plus 1 elements. You have to do the same problem again and again, which will be nothing but O of n into k log k. Do you think it can be possible? See, your n is 1e5. Your k is nothing but less than n, which can also go up till 1e5. So in worst case, it can go beyond 1e8. Although the condition is from 1e8 to 1e9, but still, let's stick to 1e8. But still, it can go up to 1e10. That's like more than 1 in 10 because log k also. That's not feasible. Which means applying your brute force logic won't work, because you can't just go on to every of those subarrays, find out the element and see, okay, if it is feasible or not to do it. Like just sort it down, bring the x, the smallest element. You can't do it because the constraint won't allow you. If you look at the constraints carefully, what we can easily see is, okay, if I have my array as n, one thing for sure, I have to go on to every element because I want to find the answer for every subarray of size k. So O of n will for sure come in my question. And n is 1e5. So at max, I can do a O of n log n or O of n log k or something like that. Like at max, O of n log something, not more than that. Now you have to think of something which can actually return you a sorted stuff, or maybe the issue was getting the x, the smallest element, getting the sorted part. It was your issue. Now let's see how we will do it. But before that, let's quickly jump on to the comments. What you guys are saying. What was your rank? Like I just did. Like as I said, for the third question, I just implemented this thing, policy-based data structure. Then I realized it was wrong. So like one wrong answer for that. And for the last question, I also had one edge case left, that your one can also be there. So because of that also, it was around 145 something, around 1500, like 150, 1500. Firstly, thought of segment trees, like what I thought of after doing a problem is, like before doing a problem is that what complexity it can go. Like the problem is never, it's a medium problem, so it can't have a segment tree as it. So for sure it can have an easy way, although it can be implemented by segment trees. But why to think in that direction when we actually know, okay, it's a medium problem, so it can't be that complicated. Lessons learned, read the question properly first, for sure. That contain constraints, wasted 23 minutes for implement. Wise n plus msk plus 1 into log n. If I do insertion short, tn equal to n into k, that constraints. So tell me monitoring stack won't work. I don't know, PDS, give some brief. Yeah, for sure. For sure, we'll go into this problem. Now let's see what I thought initially. So firstly, if I have this array and I want to grab the k consecutive elements, I think of, okay, if I just have some operation and get the x, the smallest element, in let's say log k time, is it possible? Firstly, if it is yes, then what I will do is I will just move on to my next element and remove the last element so that I can get the next k elements. Which means I was thinking of applying a sliding window approach, that, okay, I have the first k elements. If anyhow I can find the kth smallest element by some, let's say at max, as I said, I can have a log k, because see, I can have a n log something because of constraints. I want it, okay, I have some restrictions that I have to bring out the information in this specific time. I can't go beyond this time. Cool. So then what we have to do in this is that, okay, I will just grab, okay, I have the first k elements. As I move on to the next subarray of size k, then I'll just grab the next element and I just remove the last element so that I can get the new subarray of size k, and that should be sorted to get the x, the smallest element. So one first thought which comes in people's mind is, firstly, if you guys are watching, then please do the like button. Please. Let's reach to 30 likes. Okay, sorry, I got excited. And so the first thought which comes in our mind is that, because, okay, we need the subarray as sorted because we need to grab the xyz smallest element, and we also have to add the next element and remove the prior element. What first thing comes in your mind is, let's use a set. If we use a set, then what operation we can do is that if I have, firstly, I will just grab the elements of size k in this whole set. Then I can just, because the set internally is sorted, it is a first thought which comes in people's mind. See, I am just showing you that how you have to reach on to what all possible ways you can think of, and then you have to discard those ways. Okay, it is not possible. It is not possible. I can think of them, but I have to also mark it as wrong. Okay, it's not good. It's not good. It's not good. Like this. Okay, first thing I thought, because I want it to be sorted, let's use a set. Because it is sorted, then maybe I can find the x, the smallest element. But one thing comes in my mind is, Aryan, I could see that elements are repeated. So for sure, the set won't work. For sure, this set won't work. So why not set? Let's use a multiset. So rather than set, I thought, okay, let's use a multiset. Then, okay, I thought, okay, let's use a multiset which is actually sorted. Then I can maybe grab the x, the smallest element from that multiset. But then, okay, one thing comes in my mind is, okay, I can just push in these k elements at a point of time in my multiset. I'll just, as I move on to the next subarray of size k, I can do is, I can just remove that particular first element and add the last element, which is the next I plus. Let's say if it is I, so I will just add the I plus 1th element and just remove that first element, so that I can get the new range. I can get the, let me change the color, I can get the new range of size k. Because I can easily erase an element in a multiset by just pointing to an iterator, and I can also add, which means insert an element in a multiset. Cool. Which means, okay, we can do it, but is the problem done? Okay, you use a multiset, then you added an element, you removed an element, you actually saw, okay, you have the multiset as sorted, but in a multiset which is sorted, how will you grab the xth smallest element? Let me go here. How will you grab the xth smallest element? Which means, let's say you have the k elements in your multiset. Cool, very cool. But how will you grab the xth smallest element? Is there anything in your multiset which can actually give you the xth smallest element? No, right? It can just give you the first element, like the smallest element or the largest element. Let's say if the multiset name is s, so it can give you s dot begin or s dot end. If actually you want to go to the xth smallest element, then you have to first point your pointer it, let's say the iterator is it, you have to point it to s dot begin, then increase your it plus plus x times to actually make your pointer reach to the xth smallest element, which actually will take x time for every of my subarray of size k, which means x is nothing but, if you see, less than or equal to k, which is actually can go up to 105. So your problem itself will actually go n into x, and also plus n into for that thing that you're also using multiset, but it can't be feasible for sure. Again, it can't be done. So we just found out, okay, that can't be done, which means you can't use a multiset right now. But in C++, we have another data structure called as a policy based data structure. See, it is very, very, very important. Although in interviews, I don't think it will be asked, but if you solve the problem on Code Forces or Code Chef, you give the contest, maybe if you have some of the interviews lined up where you have to solve the problem in your coding rounds, which is the initial OA online assessment round, then it can be very useful. And I'll just show you that how these things which your set and multiset can't do, this policy based data structure, which is, I'll show you exact documentation that from where you can read it. I'll just give you the brief idea, but still I'll just show you that how you can actually do it. I'll just quickly show my screen that it is one document which is super helpful. I'll just ping it to you guys. Where is my chat? Yep, it is policy based data structure, and here is the link. and here you go. How I can pin it in this message, and it is done. So cool. This is the document which you can look for the policy based data structure. Now I'll actually show you how this can be feasible. The things which your set and multi-set cannot do, but your indexed set it can do. But before using this index set, you have to include header and also to actually initialize that your indexed set is of the type int. See, firstly, it is not required for this problem. Your problem will not be solved by this, but it is what I thought it can be used, but I forgot that it cannot work for duplicates. If you have to make it work for duplicates, you have to bring in a pair of value and something else also, maybe the count or something. So actually make that element as unique. Although you can actually apply index set, but then you have to change your int, which I'm going to show you. As you can see right here, the element which will be inserted in your index set is of type int, rather than int. If you make a pair of int and let's say index, then it will actually work. So actually make this index set work, you have to modify this int as a pair of int comma int, and it will work. But yeah, for now we have a much easier way to solve this problem. But yeah, it is very helpful if you're actually gonna see the competitive programming problems. But yeah, before further ado, please, if you're watching this and if you're liking this, then please do the like button, please. And yeah, let's go on to the next problem. Next thing in this, firstly we added this header, we added this index, like initialize that. Then how to use that? Firstly, as you initialize a normal set or something, same way, exactly same way you initialize this. You have this index set, you can insert the elements 2, 3, 7, 9. Now it has two major operations. The standard operations which a set can do, it also has, which means it can erase an element, it can also insert an element. But the new things which it can do is that it can find an element by the order. Which means if I just ask you, if I have an indexed set of elements, which means 2, 3, 7 and 9, return me the third smallest element. Third smallest element will have the index as 2. Third smallest element, let me quickly show you guys. I will take the same example. 2, let me quickly switch. Cool. 2, 3, 7 and 9. I just inserted that in my indexed set. INDEXTC indexed set. Let's name it as S. Cool. I just inserted that. Now what happens in this is that, okay, now it is inserted in the ascending order 2, 3, 7 and 9. I just asked you, okay Aryan, what is the third smallest element? Third smallest element is nothing but at the index 2. So it is, our indexing is 0 based in it. So if you want to find the third smallest element, you can actually go on and find the value at the index 2 by nothing but s dot find by order of 2. 2 is nothing but value at the index 2, which is actually the third smallest element, and it can actually return you the third smallest element, which is nothing but the pointer to this element, which is your IT will point here at 7. It is not the value. It is now pointing to this. It is how standard your s dot find work. It just gives you a pointer, which means it points to that value. Cool. Then what it will do is that it will ultimately go and see. Now you have got the pointer to this location, but you actually want to find the number itself. So you just have to get it by IT and just iterate, like just pointing and bringing down, like getting the reference of that by star of that IT. If I just quickly show you that how it is done, if you just go and quickly see here, you can see it find the index, it find the element in the index 2, and it is a 0 based indexing. So it just gives you this number 7. So this star x is nothing but, firstly I have this iterator, x is nothing but an iterator, and the value at this iterator is nothing but this 7. Another major thing is in this particular I'll just quickly show in this indexed set, another amazing thing is x s dot find by, order by key. Let's say you give any key. What it will do is, I'll show. What it will do is, if you just see s dot order of key, damn, then what it will do is, it will get the position of 7 in this whole set, which can actually help you to grab the position. If you have the position of that element, you can just say, okay, I just want to remove this element at this position. You can just grab the position, you can grab the number, then you can just have the iterator to that index, and you can just remove that index from there. So this s dot order of key will get you the position of 7 in your indexed set. It is how it can be helpful to find the x, the smallest element. But the only caveat here is that it only works when the elements are unique. But if by any chance you want, let's say I want to use index set, you can, instead of this int, you can make it a pair of int comma int, so that you can make every element as unique. Because here in this, I'll quickly switch back. Here in this, you have to make every element as unique. So you can just have, okay, the element, let's say nums of I, comma I. It will be now unique. Every element will be now unique. That's how you can use your index set. But I just showed you that how your indexed set can actually work. Let me quickly go into the chat. It is how you guys are doing. See, it was not required at all. Just quick thing, it was not required at all for this problem. It can be solved very easily. So next we will actually see that how it can be solved. See, as I told you, directly indexed sort indexed set, it can't work. But the much easier way to actually bring out how it can work is by looking at the constraints again. Let's see how. If I just go back and look at the constraints, the one thing which I thought was, okay, my complexity should be O of n log something, but my ultimate aim is that I am not able to find my x, the smallest element. I can actually go on and, okay, if it is my whole subarray of size k, if firstly, like before this, if you guys are watching, then please do the like button, please, if you guys are liking it. If not, then you can also dislike. It's up to you guys. If we have, I know that many people thought of it, the stream would be at 10 p.m, but we are having it at 11:30 a.m. It's because, like, we will try to have the stream at 11:30 a.m. only, because it's much easier, much faster, and it's just after the contest, so that you can actually grasp the question and the answer both. Cool. Firstly, my first thought was, okay, I'll just grab this subarray of size k, and I can also move on to the next element, which means I can try to have a sliding window approach and add the next element and remove the first element of that subarray of size k. Okay, it is how I can move in my subarray. But the thought was how to grab the x, the smallest element. X smallest element we are thinking of. Have we ever looked at the constraints of the element itself? No, right? You see that elements are only 100. At max, we can have only 100 elements, which means ultimately I have to check for your x, the smallest element. It can be only up to 100. That is so amazing that I have my n as this, my smallest element, which means my x can be from minus 50 to 50, which means in total 100 elements. Minus 50 to 50, minus 50, minus 49, minus 48, like this, up till 100 elements. That is how I can actually utilize this whole thing to grab what? Grab my answer. How? See, I just know one thing. Let me quickly show you. I will firstly grab this subarray. Okay, I can grab this subarray of size k, and I can grab every subarray of size k in just O of n by using a sliding window, that I can just add another element and remove that first element. Okay, as I have got this subarray of size k, now my main task is, okay, Aryan, what is the x, the smallest element? X smallest element. And I also know my elements, it can be from 50, minus 50 to 50. Cool. Minus 50 to, let's say the element is EL, is 50. What I can do is, I can actually keep the count of every element. See, my ultimate aim is, okay, what is the x the smallest element, which means it can be something like that, say minus 50, minus 50, minus 40, minus 40, minus 20, minus 20, minus 10, minus 10, 10, 20, 30, 30. So okay, like this. Now I hope that you guys can see it. If yes, then please let me know how's the stream going. Sab changa si everything. When I say sab changa si, is mean everything is super cool or not. Yeah. Now let's say I have this nums. Let's say I have this my sub array of size k like this. Cool. Now I want to grab the x. Let's say x the smallest element is, let's say 8 the smallest element I want to grab, which means I have to go on. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I have to grab this 10 minus 10 should be my answer. But I cannot go on to this whole subarray of size k. But one thing I can know that at max it can have 100 elements. My subarray of size, which is actually 1e5, it can go up till 1e5. It can have at max 100 elements, 100 unique elements. So what I can do is I can store the count, which means I have element as minus 50, the count is 2. I have the minus 40, the count is 2. I have minus 20, the count is 2. I have minus 10, the count is 2. I have 10, count is 1. I have 20, count is 1. I have 30, count is 2. Now I just for sure know that in my subarray now will have at max 100 unique elements. Now I can actually go, okay, I want the x the smallest element. It is now x the smallest element. Let's count the element. Up till so far the elements are 2. Up till so far the elements are 4. Up till so far the elements are 6. Up till so far the elements are 8. Which means your 7th and 8th smallest element is nothing but minus 10. That is what we have to do. We will just have a map in which I will just store the count of every of my frequency of numbers in my subarray of size k. Then what I will do is I will just go on and check. As soon as my count becomes more than or equal to my actual x the smallest element, I just go on from minus 50. I just go on to my whole map from minus 50 up till 50. Which will have everything, minus 50, minus 49, minus 48, minus 47, everything. But here the count is 2, here the count is 0, 0, 0. But no worries, because it can at max be up till 100. So what I will do is, I will go on to this whole thing from minus 50 to 50. Then I'll just see, okay, count, 2. Okay, nothing but no worries. 2 is still less than 8, which means I have to again go. 2, which means now the sum is 4, it's still less than 8. 6, it's still less than 8. 2, 8. As soon as, let's say if it would have been 3, so it would have become 9. Your sum would have become 9. As soon as your sum, which means the count of numbers right now becomes more than your x or equal to x, which means that, okay, you have found your x the smallest element and it is nothing but your x the smallest element. It is how easily it can be done without knowing anything like policy based data structure, indexed set or anything. Shivam Goswami, dope stream. Thank you, bro. So I hope that you guys have got the idea and intuition, okay, how we actually go, because we know, okay, we have to go on and look at every of these subarray of size k in O of n. So I can only apply the sliding window approach. Okay, I have applied the sliding window approach, but now my main task is to find the x the smallest element. I tried applying multi-set, set, everything, but nothing is working, which means I have to apply something else. Applying something else, which means, let's look at the numbers itself, which means that I just checked, okay, the numbers itself in a subarray of size k, it can at max be up till 100. So I'll just go on to every numbers, check the count of that number, because if it is 2, and I want the 8th smallest element, so it will for sure be beyond. If this number 10 had the frequency of 1, and let's say it would have, let's say, the same frequency 1. So far the count would have been 7. Still it is less than 8. Now it would have reached here. It is now 8. So my 8th smallest element would have been this 10 rather than this minus 10. But I have said that if the element is positive, you have to return a 0, because the answer was saying that if the number is positive, you have to return a 0. It is what we have to do in this whole problem. I hope that you guys got the entire intuition that how we think of every step. Okay, it is sorted. We have to to do something like this. Okay, we tried of n log n approach, n log k approach, but nothing is working. Now we need to think of something else. What else we can think? Have a look at the constraints of every part of the problem carefully. Is the constraints, it can help us to figure out, okay, what we can do, because the constraints are just best thing to actually reach to a problem. Okay, what we are thinking and what we are not thinking. Now, I hope that you guys have got it. Let's quickly code the problem. It's also pretty easy. Before that, if you guys are liking it, then please, let's reach the 40 like button target, and we would be good to go. Let me reset this whole thing. Now, what will happen is that, firstly, my first main task was that if we just quickly go and look, I have this element, I want the range, but before that, I just wanted my sliding window approach because I want to reach to the next element. So what I can do simply is I can just maintain, okay, I'll just go from I to k minus 1 because see, I just want my window of size k. So how I usually do is that you can actually apply anything. Firstly, I need to maintain the count of every element. So let's use the unordered map stuff. Now, our unordered map is used. Now, what we had to do was we had to start and go. But before that, one thing was pretty sure that I just wanted to keep track of every element from minus 50 to 50. So although it's not required, you can actually modify this any of your own ways. But it's a very very normal intuitive idea which I am having, that okay, I'll just initialize my every of those element count by 0. Now my map is ready. I have the count of every element as 0. Cool, every element count is 0 now so far. But before that, before actually start applying my operation on my array of size k, which means at every step I was thinking, okay, I will just add an element, and when my whole array, my whole function, my whole part is done, I just remove the first element. Cool. And for every of those, I need an answer vector which will actually store the answer. As I'm saying, let me quickly show. See, as I said before starting on, my first thing was I will start with the array of subarray of size k, which means my length was from 0 to n minus 1. I have to start with a subarray of size k, which means from 0 to k minus 1. So it is the first element which I can add. So I will just firstly, what I do is I just firstly put this and start with this thing. I'll just initially add this thing, and it is what I will do. At every step, I will add this element, and when this whole step is done, I will just remove the first element. It is how I try to do it, which means let's go on to the problem back. It is how you will do that. I will just start from 0 up till I is less than k minus 1, which means I have the array of the subarray of size k, which end at k minus 1. But I don't want to end at k minus 1 because I will just start with k minus 2, which means elements are now k minus 1. I will just firstly update the count of those elements because now I'm just working on the counts. I have no worries about the number of elements right now. Now, actually, I will start with the first kth element, which is nothing but k minus 1. Then I have to go up till the end, which is nums.size, because at every step, what I will do is I will add this element, and when the whole step is done, I will remove that element, which means I will firstly add this element, which is nothing but nums of I. I will add it, and when my whole process is done, whatever process I had, the process was to find the x smallest element. When it is done and I'm moving on to the next element, I have to remove my I, which is the current index I minus k plus 1. I'll show you how. Let me quickly see. Yeah, if now it is done, I have to remove this index. I am at k, I am at I. I have, see, whenever you are about to perform these operations, just whenever you are very worried about the indexes and all that stuff, just quickly go and look at the problem statement itself. You have minus 1, 3, right? And minus 2, 3. The size was k. Here I equal to 0, I equal to 1, I equal to 2, right? I equal to 2. and you have to remove this. So you have to do I minus k, which is 2 minus 3, but it will land to minus 1. You have to reach 0. So you can do a plus 1, plus 1, plus 1. So you have to remove the element I minus k plus 1, which is nothing but a 0. That is to actually, whenever you are confused in your life about the indexes, then just do something like this. Thus, I am just reducing this particular value of this index. Now, okay. Currently, I have in my map the elements. Now, no worries. I will just do a simple count. As soon as my count number reaches more than, as you know, I have to iterate on every element from minus 50 to 50. Right. I have to go on from minus 50 to 50. So what will happen is, I have to go on from every element from minus 50 to 50. I just firstly increase the count, which means CT plus is equals to MP of that particular J. So far is the count. As soon as my count reaches my Xth value, Aryan, I have found the element I needed. I will just push back that element in my answer because it is the Xth smallest element of this array of size k. Element is nothing but J. As I have found it, so I can easily break from here and I'm good to go. Ultimately, it will just break out from this particular loop. As the count has gone, count is being increased for every element of J by this MP of J, and then you can actually break out from here. And ultimately, before leaving, you will actually reduce on the first element of that K subarray. Ultimately, you can return your answer. Let's quickly check if we are not doing any problem. Oh, lovely. We're not pushing anything. It was not going. Oh, minus K plus 1. Let's start with K minus 1. Minus K minus 1. Cool. Minus 1, minus 2, minus 2, minus 1, minus 2, minus 2, minus 1, minus 2, minus 3, minus 4, minus 3, 1, 3, minus 3. Okay. It's actually a 0, which means that it is counting it as 1. It is returning a 1 here. Rather, it is okay. If you remembered one thing, one condition was that if the element is negative, if the element is positive, we have to return a 0 instead of a 1. So what we can easily do is that if my CT has become, then I'll just check here if that element J, if it is more than 0, then just push in a 0 rather than that element. Else, we can just itself push in that negative element. Let's quickly submit. I hope it should work now. Let's quickly see, and it is accepted. So yeah, that was. Let's quickly chat. Go back to the chat, and yeah, you guys have not liked. Like karo yaar. Please like. In English, please like. Someone tried sliding window plus quick select. If the element is positive, then it is 0, so could keep all the positive integers in a single index R8, so we should traverse only once 552. Yeah, correct. That is also correct, but how come it's like 50 or so it doesn't matter. Yeah, but that is also correct. What? Anything else? Anyone have any doubts, or is it good? Shall we move on to the next problem? 4. Problem 4. As if I am selling some bottles in a bus. But before that, please like. Yeah, that's one like right here, and that I loved it. And before that, anyone has any doubts, any problems in problem 3rd, anything else you wanna listen, hear, see, discuss, or shall we move on to the next problem? Okay, cool. No responses as of now. I hope that you guys have liked it. Let's move on to the next problem, which is your problem number 4. That was an interesting problem. How? Let's see this problem. Firstly, we are having your minimum number of operations to make all array elements equal to 1. The problem was saying that you are given a 0 indexed array nums. Someone is saying something. Kunal sorry, I pronounced Kunal. By next function, also tell why monotonic stack won't work. That monotonic stack. What do you want to say by that? I don't know. PBDS. Give some brief. Yeah, I've given the brief of that. How much time did it take to solve first two? It was 3 minutes or 2, I'm not sure. N plus m minus k plus 1 into log n minus k. Okay, that constraint. Notice it after 30 minutes. Yeah, constraints, we have to look at them first. Yeah, we will actually go on to these kind of problems, that how to prepare for online assessments and all that stuff at the end of the stream. But yeah, you can actually post the questions. You can just go back and quickly look at the stream. Also, after the stream ends, after the question ends, that we can actually move on to your problems. But yeah, before further ado, let's look at this particular problem right here, which is minimum number of operations to make all array elements equal to 1. Before further ado, if you have not liked yet so far, and if you're watching it, then please hit the like button. Lovely, that would be lovely. You are given a zero index integer array called as nums, consisting of positive integers. Array nums, standard, positive integers, cool, very standard. You can do the following operations on the array any number of times. Operation is, you can perform. What's the operation? We'll see. But you can perform that operation any number of times. Cool. What is the operation like? You have to select an index I, no worries, such that I is from in the bounds of the array. Cool. Replace either of nums of I or nums of I plus 1. I have to select an element, index I. I can choose index I, which means nums of I, or I can choose nums of I plus 1. What I can do is I have to replace any of those, which means nums of I or nums of I plus 1, with their GCD value. GCD value of two elements is nothing but GCD of A and B is nothing but greatest common divisor, which is underscore underscore GCD of A and B can give you the GCD of two numbers A and B. It is just the greatest common divisor. The divisor which is greatest common in both of them. That is your GCD, and you have to replace one element right there. Return the minimum number of operations to make all elements of nums. My words, all elements of nums equal to 1. If it is not possible, return a -1, which means my ultimate aim target is to make all elements equal to 1. And if it is not possible, Aryan, how it can't be possible? We will see that. But if it is not possible, we have to return a -1. It is just saying that what is a GCD? We for sure know what's a GCD like. Yeah. Let's look at what the example itself are saying. If we had 2, 6, 3, 4, let's not look at what's the problem saying. Let's try to manually try and make your entire array as 1. 1 for sure. By just looking at it, I just can quickly grasp, okay, if I just do a GCD of 2 and 6, it will give me a 2. Cool, no worries. If I do a GCD of 6 and 3, it will give me a 3. No worries. If I do a GCD of 3 and 4, it will give me a 1. 1, which means, okay, I can make any element as 1. 1 right here and 3 right here, let's say. That was nice, I guess, Aryan. Yeah, that was nice. Now, what will happen is your new array, which means in the next one operation is done. And the array now looks something like this. You have replaced one element by the GCD of this. What I thought initially was, I have to make the whole GCD as 1. So let's try and like greedily think, can I initially make the GCD as 1 itself? Maybe not. If I can, then let's see. If it is 1, in the next step, I can just grab, because any number GCD with 1 will be a 1. So it is one thing I knew, okay, any number GCD with 1 will be a 1. So I can just grab this 1 and it will become a 1. Now it has been 2 operations right there. In the next operation, I can just grab this whole GCD. It can again become a 1. In the next operation, I can grab these 2 pairs and it will also become a 1. In total, 1, 2, 3, 4 operations, you have made your whole array as 1. Aryan, you just thought, okay, we should grab the two elements as the GCD as one. I just thought, okay, very greedily, I just thought, anyway, if I can see one option, I would have grabbed is, okay, let's grab this whole two problems. Let's grab these two particular pairs. Can you do a vlog on Goldman Sachs office? That's not allowed. Like initially, one day I just recorded some things, not in the office, but in the park of the office, but it was not allowed at all. So I just have to not post that. But yeah, I have vlogged in house and also in the stuff where I live in. I will post that, but I don't get the time to edit it. So, but yeah, I will post that for sure. Harshit Meena for sure. Yes, but before that, let's see what other thoughts we can have. Okay, first thought was greedily we had to make the array as one. So I just greedily thought of let's choose a pair which can actually give me a one. Actually can have a one. Oh, I just read a comment and I just got to start it. I am new to your channel and your explanation is very nice. Appreciate it. Thank you. Thank you. But let's see. So one thought, okay, I had this greedily, but let's say I have not thought it as greedily. Then what option I could have is I will choose two pairs. It will have the GCD as 2 and 2. The array would look something like this. Let's say now I choose the pairs right here. It will become a 1, 3, 4, 2. Now you saw what happened. It again became the same problem which we did in one operations. 2, 6, 3, 1. In two operations, what you made the same thing in the one operation. Which means once you have made one element as one, it's for sure you will make the entire array as one. For sure. That is the reason. It's always thinking greedily is always better to actually say, okay, I will just take two pairs out which can actually have the GCD as one, and then I will just grab a location something like this where I will have two pairs as 2, 6, let's say 3, 1. Now if I have made my one element of this, let's say if initially your element has no one at all, but once you have made one element of your array as one, then for sure in n-1 step, if the length of this is, let's say, n, your array length is n, right? Num's array of size n. So if one element has become 1, and for sure, remember, I have used one step to actually make it a 1. If it has become a 1, one element has become a 1, then for sure in n-1 steps, I can make all elements. I will just in one step, I will make all these two ones, which means it will become a 1. In the next step, I will make the next pair as 1. It will also become a 1. In the next step, I'll make this pair as 1. It will also become a 1. So if one element has become one of your array nums, you in n-1 steps, you can make your entire array as 1. Aryan, that looks nice, right? What I will think of is, Aryan, what if I do something like this? In one step, I will just make this as 1. Now the elements are 2, 6, 3, 4. One step already made to actually make this as 1. Now the elements remain are 4. And you said that if you have one element as 1, to make the remaining elements, you can just, whatsoever remaining elements are there, let's say elements remaining are 3. So it will just apply operations 3 to make all of them 1. So it will just apply n-1 operation because the non-1 elements right now are n-1. It is the answer. So 1 plus n-1, it is the answer. Is it the answer? Is it the answer? You assumed one thing. You remembered one thing you assumed. Firstly, let me know why it can't be the answer. Write down in comments that why the approach I showed you. Maybe it is the answer, maybe not. Just let me know right now below why it can't be answer. As you write, I'll just explain, okay, why the next case is -1 and how to reach to this -1 case. But as I'm writing, just let me know down below that why it can't be the answer. Just give me a case that where it will fail. I will just grab two pairs which will have the GCD as one operation done, and next whatsoever non-1 elements are remaining, I can make them as 1. In those non-1 elements, non-1 elements, whatsoever non-1 elements. Let's say the elements non-1 elements are, let's say 3. I will have 3 plus 1 operation to actually make that pair as 1, and we are good to go. Just let me know why this have there may be many ones in the array. Okay, cool. But I'll just say, okay, if there are many ones in the array, if I have 2, 3, 4, 1, 1, 3, 2, then still I can just say, okay, the number of see, one operation was to make 1, 1, right? Okay, I'll just say operations are 0 right now because 1 is already existing in my array. So number of non-1 elements are, let's say right now 1, 2, 3, 4, 5. So is the answer 0 plus 5? 5. Will it work for every problem? Which means my one operation was to actually make, my one operation was to make the one of those elements as 1, which means I just grab a pair and will make it as 1. And next was, as soon as 1 is present, I'll just grab what are the non-1 elements, and all of them can be made 1 in those non-1 elements number of times. Will it work now? Response. If not, then please do the like button. If you are watching it right now, then please do it. So, will it work? But before that, let's see why it is -1. It is just saying that no way it can have all the elements as 1. Which means that it is saying that no way that even one element will actually have 1. You can actually see why. Which means that no pair in this can actually make you a 1. Or why, Aryan, why you are saying always pair? Why pair is important? Maybe I have the array, let's say something like 2, 6, 3. It is not a pair. It is not possible to make 1 in 1 operation. Correct. That is the answer. It is always not possible to make 1 in 1 operation only. Which means that in this problem itself, you see 2, 6, 3. In this, you will see that to make a 1, you will see, okay, the adjacent ones, it will have a GCD as 2. The adjacent ones, it will have a GCD as 3. So in one operation, you cannot make this as 1. But is it saying that you cannot make a 1 at all? No, you can make a 1. How? You will just grab the GCD of both of these elements. You will make it as a 2 and 2 because the GCD is 2. Now you have the array something like this. In the next operation, you will grab this particular elements, 2 elements right there, and you can make it as a 1. You saw what happened. In 2 operations, you made an element in this array as 1. Which means, for sure, the operations, it can be high to actually make your 1 element as 1. And as soon as your array gets one element, then number of operations required next are just 2 more, which means number of non-1 elements. And in total to get 1, I had 2 operations. In total, the answer will be 4. But our question was that how to know that the answer is -1. You saw what has happened. Ultimately, what GCD is doing is, it is making your answer shorter and shorter. Your 2 and 6 when combined, which means when we had the GCD. If you guys are watching, then please do hit the like button. Let's reach to the 50 target likes. Let's hit that, smash that, spam that. Do whatever you want to do. I don't know why you want to spank your phone, but if you don't have a GF, then it's the only thing which you can spank. And please don't spank me. Yeah. So what we can do is that, okay, every time we do a GCD of 2 elements, it gets either smaller or remains same, which means it will get small. Next time I am grabbing the GCD, it is getting small. So every time some element, see, it is the property of a GCD. If you have some elements, every time you do a GCD with some elements, then what happens is your element will become smaller, which means I have 2, 4, 8, 6, 3, 1, 3, 7. So here the GCD is 2. With 8 coming, still it will remain 2. It will never increase. It will just reduce. Next comes is 6. It will become again 2. Next comes is 3. It will become 1. You are seeing what's happening. Ultimately, the GCD is reducing down. And here you can easily see that your GCD was reducing. Okay, 2, 10, 6, 14. it is reduced to 2. It is reduced again to 2. It is reduced again to 2. It never reduced back to 1, which means for sure you can never, ever, ever, by any pair, any forms, any way, you can get a 1. While in the case which we saw right here, if you just grab this, you get a 2. If you grab this, you get a 1. If the whole GCD of this entire array is 1, then for sure, in any ways, you can get a ultimate 1, 1, 1, 1, 1 as the GCD. If not, then no way possible you can get a GCD as 1. So ultimately, before starting off our problem, we will just check if the entire GCD of this entire array, if it is 1, then for sure we have a way. But if it is not 1, then for sure we don't have a way, and we have to return a -1. Cool. Now, okay, we have got the way of -1, and while discussing the way of -1, we also found that my ultimate aim, let me go back. My ultimate aim was to actually make one element of my array as 1. Right? As soon as it becomes 1. If it is present, good, very good, no worries. As soon as one element becomes 1, the number of non-1 elements, my count will be nothing but that number of non-1 elements count. Okay, non-1 elements count. It will be my count. Cool, no worries. Now see, as Bhavishya said that to make the count, to make one element as 1, it's not necessary that it can be just made in one step. And we also want to use a minimum number of steps, which means let's take this example as 2, 6, 3. I want to make one element as 1 in this whole array of count. Now, what will happen? You just grab two elements, and you can just make, okay, 2, 2, 3, and you can just make it as a 1. As soon as one element is done, you can just say, hey, you saw one thing. You took 3 elements, you applied operation on those 3 elements. So you got, okay, your one element is 1. Is it possible that you can just grab 2 elements? Is it possible that you can grab the 2 elements right here? Is it possible? No, right? And what if I had said, hey, no worries, Shashank, Bhavish, MS, Darshan, Harshit, Yash, if I just ask you guys, what is it possible that, shall I just one more like and we can reach 50k likes? Sorry, 50k likes. What I'm imagining, 50k is like just a dream. But yeah, if I had, let's say 4 right here, or let's say 8 right here, would have been good that I apply operations on every of those. You saw what operation I'm applying. I'm applying operation on the 2 consecutive pairs, right? To actually reach 2, I just reached 1 element. Was it good that I just use this whole thing? No, right? Because it was sufficient to actually grab this particular sub-array part and make my one element as 1. And I'm simply doing one thing. I'm doing the GCD of kind of all the elements to actually reach to one element. Which means that if you have this particular sub-array and you can make one element as 1. In worst case, what can happen? If you have these elements, in worst case, do the GCD of these 2 elements. Let's name it as A, B, C, D, E, F. In worst case, what you can do is you can do the GCD of AB and make A GCD B. Let's name it as A comma B, or let's name it as AB. Let's name it as GAB. Cool. Then what you can do is you can do a GCD of these 2, make it as a GABC. Then make a GCD of these 2, make it as a GCD of ABCD. Then do a GCD of these 2, make as a GCD of ABCDE. Right? Then make a GCD of these 2, make it as a GABCDE. Then you one thing for sure know, by doing a GCD of my sub-array, I can just say, okay, if I have to make one element as what I imagined, then if that sub-array GCD is 1, then for sure my one element can be 1. Right? You saw, if your GCD of this whole subarray is ultimately becomes 1, then you can for sure say that, okay, I can make my one element as 1. Now your task is reduced to that you want new number of operations. So you will choose the smallest subarray of which the GCD is 1. Why smallest? Because choosing the smallest subarray which will actually make you sure that number of operations applied, because let's say the array size is 3, so number of operations applied to make the one element as GCD will be nothing but array size minus 1 will be your operations to make one element as 1 if 1 is not present. As simple as that. So here the array size is 3, so number of operations required to make one element as 1 was 2, because one operation, next operation, number of pairs, right? And that is how you will make one element as 1 by applying array size, which is the smallest subarray having a GCD of size 1. You will just reach, okay, array size minus 1 will be the operations to make one element as 1, and then what you can do is you can just say, okay, what are the number of non-1 elements, and that is how you will be able to do it. That is all what you have to do in this problem. You saw how we thought of every of the small part. Okay, let's do the GCD. Let's see how it can be done. Let's see how we can make one. Is it always possible to make one in one step? What is the minimum number of steps we have to reach to actually make it one? All that stuff. If you guys are liking it, then do smash the like button. Now we will actually start coding this. It's exactly the same how we will code it. We will actually grab, okay, it is my, and see, the constraints are pretty low. N is nothing but 50, which means I can apply a brute force solution. I will grab all the subarrays, n square subarrays are there. For every of these subarray, I will actually go and look and find the GCD of that subarray, and I will check if that subarray GCD is 1. Very good. I will just grab the size or the indexes of, firstly I will just grab the size of my subarray. Let's say if the subarray was from I to j, then the size of the subarray is j minus I plus 1. I know I will just grab this size. I want my minimum size subarray. I will just say, okay, it is my minimum size subarray. Then number of operations required to make one element as 1 in that minimum size subarray will be nothing but that size minus 1. And when my one element has become 1, next operation will be to make number of non-1 elements as 1, which will require the operation as non-1 elements. Why I am saying non-1 elements and why not all the remaining elements? It's because it can be the case that we already have an existing one. Either you can just say, okay, Aryan, just initially have a check that if you have existing one, then you can just easily return the answer is number of non-1 elements. You can just opt to do in this way only, or you can just say we can also have, because see, if you have a one element, then the GCD subarray will have the size of 1. With this, your SZ will be nothing but 1. So SZ minus 1 will be nothing but 0. So that number of ways to make one element as 1 will be actually 0. So you can go either ways. You can just actually have the initial condition that, okay, if any element is 1, then just return number of non-1 elements and it will be the operation required. Else, just try to make that one element as 1 by just grabbing the smallest size subarray and making one element as 1 will be nothing but that size minus 1 and the minimum number of elements, which is nothing but n minus 1. Let's quickly start coding. Let's quickly hit the like button, smash it, spam, demolish it, do whatever you want to do, but just hit that. Let's quickly code the problem and let's see how it can be done. Let's reset this part. And firstly we have that first condition, that what if we have to return a -1, which means your GCD, let's name this as a value. Value means the GCD of your entire array. If that GCD of your entire array is not 1, for sure in no ways you can make your answer as 1. So just do a GCD. See, there's an operation called as __ GCD in your C++, by which you can grab a GCD, or you can implement the function also. It's also pretty same and simple. What we can do is we can just grab this GCD of the entire array. We initialized this with 0 because GCD of any number with 0 remains that number itself. 0 never affects the GCD of any number. Thus, I'll check if that value is not if it is not -1. If it is not 1, sorry, then ultimately I cannot make it. I have to return -1. For sure, I'm very sorry, but I have to do it. I can just have a check also. Let's have a flag or something like this. I'll just check, okay, if one element is 1, I can just have the count of those elements. Let's have this count also. It can actually help us make it faster, that I can have a count of my element. If the element is 1, then I can have let's say the flag ++, which means it is the count of number of elements. If one element is 1, it means my flag is not 0, which means, okay, one element was 1. Then for sure the number of non-1 elements, or you can also have that, okay, number of ones, yeah, number of ones, you can have at it as whatsoever number of ones are there. If the ones are actually there, which means you have ones in your answer, for sure you don't have to make an element as 1, and you don't have to apply the operations. You just have to make all the non-1 elements as 1. So I'll just return number of elements which are non-ones, which means I have total, in total I have n elements. Let's क्या होता है? Lats मार रहा हूँ मैं यहाँ पे. I'm not, if you know, lats are just exercise. You guys for sure must be knowing, you are the gym freaks. But yeah, I will just return the number of n, which means number of non-1 elements, and it would be my answer if I have some ones. But what if I have no ones at all? Then I had a task. I have to find the smallest subarray of any size that its GCD is 1. So I can just take a vector in which I'll just grab the sizes of all these subarrays which have the GCD as 1. For that, I have to iterate on my every subarray, which means I'll go from 0 to n-1. Then for grabbing, I have to go on to the next, because see, for a subarray you need an I and a j index. So I'll just grab the j index. It will be nothing but your same, moving from I to n. Now I have this as my subarray from I to j. Now I need to grab the GCD of this subarray. So let's have my another variable which will actually start from I and will go up till j. And with this, what will happen is I'll just grab the GCD of this particular subarray. Right? With this, what will happen? You will see. I'm just grabbing the GCD of this subarray. It will be nothing but nums of k, because I have my nums. Now, as soon as this value becomes 1, I have found the GCD of that subarray as 1, which means I can push it in my vector. I just wanted the, see, you can actually have the one variable. No vector is required. Let's remove this vector. Let's name it as the minimum size. Minimum size. Minimum size. Yeah. What is the maximum size which can have? 50, right? Let's have it as 100. Now, if it is 1, so just update the minimum size, which is nothing but minimum of minimum size, comma, what is the size of this subarray which has the GCD as 1 right now? It is nothing but j minus I plus 1. It is the size of this subarray. Cool. At the end, I will just grab the subarray. What is the minimum subarray size? Then ultimately what I have to return is minimum sum, minimum size minus 1, because it is the operation. It is operation required. It is operation required to make one element. Remember, one element in that subarray as 1. It is the operation required to make one element as 1. Minimum size of that subarray, which is the minimum size, minus 1. But now the remaining elements are non-ones. So remaining elements are nothing but n minus 1 elements are remaining. That is non-1 elements. That is all which we have to do in this problem. Let's quickly test and see if we have not done some silly mistakes. 4 and 1 minus 1, 4 and minus 1. Let's try to quickly submit. If you guys have not seen, it is accepted. So that was all that we just have and choose to do this. And I hope that you guys got the proper intuition at how we are doing and what we are doing right now. You guys have not lied down. Yaar, like karo bhai. Brothers, bhai, fellas, like it down. Now, the contest is done. If you guys have any other questions, we can just wait for 5-10 minutes for any of your questions. Ask, I didn't notice the constraints. Wasted 45 minutes to figure out the answer and ultimately didn't get the solution. And move to the later question. Sai Shri, no worries, bro. No worries. It happens a lot that we just miss out the constraints part a few times and it just fucks up our mind. But yeah, I hope that you guys liked it. If yes, then do let me know of any improvements, anything you suggest, any questions you have, any doubts, anything which you guys want to ask right now, any suggestions, anything which you want to say. We can have a quick discussion until my camera battery dies. It have the capacity of around 45 minutes more, but still, if you guys are liking it, भैया online assessments के लिए कैसे prepare करना है? See, for that, first just go on through the basic things in DP, graph, binary search, arrays. When I say arrays, it's 2-pointer and also like the standard algorithms like Cadence algorithm and all that stuff, because it's very standard that in an interview, in an online assessment, they have 3 or 4 questions. It's majorly 3 questions, in which the first one is medium or easy medium, next one is medium, and the last one is hard. The hard one, many times I have seen as on DP. See, never ever fix that stuff. That it will be fixed, but it can be DP, it can be anything down, but it's mostly DP because a DP is a bit hard to think. It's high chance that your problems will be either DP, graph, binary search, or the standard array or the string modifications. So it's very good that you just have a grasp of these basic concepts. Okay, just go on to 1D and 2D DPs and just go on to the basic graph algorithms, just go on and do the standard binary search, and just like never focus on everything. Like let's say I have to complete the entire graph before starting the graph problems. No, just do the basic BFS, DFS and just jump on the graph problems, because 80% of the problems will be solved by just the standard problems of graph. So it's highly recommended that you just do those basic stuff done and then quickly move on to the problems. Just give more and more virtual contests. In Leetcode you can have the virtual contests and stuff, so just give that virtual contests and stuff and you would be good to go. Is memorization enough, bro, or should I do tabulation and space optimization? Memorization is more than enough in many of the interviews, but if you have and you want to have a long-lasting impression on the interviewer, then you can just try to think of tabulation or the bottom-up approach also, because see, in optimization, in the problem of DPs, optimization can only be done when you have performed the bottom-up approach, which means that it's of no worries to actually have a look at the problem. I always prefer that whenever you are in the contest, just start with the memoization approach. In 1D DP, it's very easy to have the bottom approach because it's actually intuitive. But as soon as the dimension increases of a DP, it becomes harder to actually think in the more dimensions from scratch, which means from bottom up. So it's highly recommended that in an interview also, because it can be a chance that interview won't even understand. Maybe you are just saying, let's say you just have this problem, but it's high chance that the interviewer might not get that. So I'll just quickly change the scene, and because I don't know why I'm speaking with that thing on. So yeah, that's the reason how you will actually do. Just a quick tip, just actually have a look at the bottom approach also. There is no harm. If you don't get it, no worries at all. You don't have to just say, okay, just try to look at the codes again and again. Just try to visualize that. What will happen with that is you will be able to visualize, okay, how the matrix is working, how the answer is being formed from because it's very hard to analyze and think of recursive problems. But if it is iterative, you can actually analyze that, okay, it is how my first state is being filled, after that my state is being filled like this, after that like this, after that like this. When you are able to visualize that, then it's high chance that in an interview, when the problem is being asked to you, then you will be able to visualize that in the iterative form also. And then maybe you are not able to solve it, but you can actually let the interviewer know that, okay, it can be solved like this. As you can see, only the iterative part is like here, and you can actually use only one time and you can have your answer with this. So like, it's highly recommended to actually look at the code. It's not necessary that you understand it very carefully. It's very important to know it, but it's just good. Solving a problem is first major priority. So yeah, that's all. If any other questions are there, so you guys can ask. Before leaving, you guys can hit a like, and in 5 minutes we can end the stream at 1:05 p.m. We will end the stream. Is CGPA important for off-campus new grads? CGPA is what I will say right now is exactly what I believe. CGPA is actually important, but not very much. See, when you go in an interview, you just bring a bunch of your qualities. CGPA just shows one thing. It never shows that you are smart. It just shows that you are hardworking. And in a company, a person, see, if in a round of Google or in any company round, you have the HR round, Googliness round, or Amazon also have that round in which they have those Amazon principles. So if you just quickly look and see, they are very much concerned about how much eager, how much hardworking you are, how much eager you are to go one step beyond to actually learn new stuff, find a new stuff, work on those new things. Thus, CGPA just showed, okay, like you are hardworking, you can put in some time, and you are also sincere back at your college days. It's not important to have very high CGPA, just maintain around more than 8 to 8.5, because see, your resume is being shortlisted by some person, and at the back of his mind, no matter what, see, if you are very good at other stuff, let's say if you're very good at programming or development or something other, let's say you have built audience very big, you having some like very big vlog channel, something like that, like you have done something else also which can stand you apart from the crowd, then it's good. You can have a lower CGPA also. But if you are like everyone else, everyone have, let's say, 8 CGPA, everyone is having that same Leetcode, same code forces, same code chef profile, everyone has done the same projects, how will you stand apart from the crowd? That's the reason. See, it's a very, very, very less effort to have a good CGPA. Like legit very less effort. If you have not watched the CGPA video, I just highly recommend that you can just go and watch the video of in which I just showed you that how it was so easy to grab such a great CGPA, and you have to only work in the last 1 month of your exams, and it's like pretty easy. You just need to have some tricks, that will actually get you those high CGPA numbers. So yeah, I hope that I solved your doubt. I understood, bro. Thanks. No worries. MS Darshan, like MS Darshan, and there was one more guy, Chetan, like, and a few other, Yash. Like, all these are very regular on our Telegram and YouTube also. So great shout out to you guys. I love, like, I remember the names when I read them again and again in comments. In like, I have read many comments of MS Darshan. So great shout out to you, bro. Real thanks. Like, it really motivates me a lot. Like, legit. So yeah, it has been 103. We still have 2 minutes left. I'll just speak on butter. But yeah, I hope that you guys liked it. If you are leaving and you have not watched it, then you can just go and hit the like button. We will be super happy to have you back next stream. Next stream we will try to have at 11 p.m. next in the next weekend. On Saturday we have the contest again. We will try to have the live contest discussion of a bi-weekly contest also. Not sure of how long I would be able to sustain this stuff, because we post content daily. Like, the Leetcode question comes daily. We also post the Tuesday, Thursday and weekends bar graph series lectures, and also now we have started our live discussions. And I also really usually vlog on weekends, like if I go out, so I have to also edit that. So like, that will also be coming up. Yeah, I also messaged in LinkedIn. I will for sure reply when I see my LinkedIn request. Like, it has gone way much. So once I was coming back from airport, so I just accepted those, but still, like, many are still pending. So I'll just write a bot or something, and which can actually accept all my LinkedIn requests, so that I can actually go and work and not manually tick. It's very hard to actually go and manually do a connection request. But yeah, I will for sure also reply on LinkedIn. Many people have, sorry, I really apologies. I could not get time to actually reply on LinkedIn, but for sure I will reply there also. Many people have messaged on Instagram also. I will reply there also. So a bit, you have to wait, but yeah, for sure. As soon as I get time, as soon as I am in between roads, I will just reply. That is all. 105. I hope that you guys liked it. That's all. Nahi, bhai, busy to nahi. Well, it's just that some office work, some making contents and stuff. Then I just love sleeping, so I just sleep a lot. So yeah, that's all. I hope that you guys have no problems. 9 viewers right now. Bye to those 9 viewers. Cool. Those 56 likes. Love those likes. You have done it, and the viewers have become 10. Cool. Bye. And see you guys in the next video. And then goodbye. Take care. Ending stream. Bye.